Okay, let's have a look at the homework first. Question 17, in the diagram at right, angle B equals angle D, which are both right angles. AB is 24, CD is also 24. And BC equals AD is 32. A, prove that triangle ABE is congruent to triangle CDE. Okay, first of all, we have AB equals CD equals 24, right? And we also have angle ABE equals angle CDE equals 90 degrees. And probably we'll find another pair of angles to prove congruence according to AAS, right? And luckily we have angle AEB equals angle CED, right? Because they are vertical angles. Therefore, according to AAS, we have triangle ABE. I'll write it here. Is congruent to triangle CDE, right? By AAS. Can you follow me, Neil? Okay, then question B. From part A, we know AE equals CE, right? Say therefore AE equals C from the AAS congruence. Therefore, we know triangle AEC is an isosceles triangle. And therefore, we know EM, segment EM must be perpendicular to segment AC, right? And M is the midpoint of AC, of course, here. So that completes the second one, right? And for the third question, the given information says, okay, AB is 24. BC is 32, right? And angle B is 90 degrees. So note that 24 can be expressed as 8 by 3. 32 can be expressed by 8 by 4, right? Does it remind you something? 3, 4, 5, right? So it's actually a 3, 4, 5 right triangle. Therefore, we know you can immediately calculate AC is actually 8 by 5, right? Of course, you can also use Pythagorean theorem to find AC. So AC equals 40, and MC equals AC over 2, which is 20, right? And okay, probably we're going to use some similar triangles as well, because angle EMC equals angle ABC equals 90 degrees. Also, we have ECM equals angle BCA, right? ECM BCA is actually the same angle, and therefore we know triangle ABC is similar to triangle EMC, right? By a similarity. And therefore the corresponding sides are proportional, so we have EM over MC equals AB over BC, right? You follow me? Therefore we can find EM equals MC times AB over BC, and We know these three sides, so just put the numbers in. 20 times 24 over 32, which is 15. So if you know EM is the altitude of the base AC. Therefore, the area of that triangle, AEC, we use this symbol to denote the area, right? Is 1/2 of AC times EM. So the key is to solve EM here. And that's 1/2 of AC is 40, EM is 15. So eventually you will have 300, right? Okay, Neil, can you follow me? Okay. All right, next one, 22. If you need more time, just let me know, okay? 22, okay. Let XOY be a right-angled triangle. Okay, it's better to draw a diagram to help us think. So XOY. XOY is 90 degrees. Here you have a 90-degree angle. Let M and N be the midpoints of the legs OX. M is here, N is here. Given that XN is 19. And YM is 22. Find the length of XY. Okay, sometimes in order to facilitate our discussion, it's better to use some small letters to denote the segment. So we can let, for example, let OX be X and OY be Y. So we'll probably need this length. Okay, let's call this side is X and this side is Y. And then we have, okay, because M is the midpoint, so OM is just X over 2. And ON is Y over 2. Then we can use the Pythagorean theorem, right, to establish two equations in terms of X and Y. Then probably we can solve the two unknown variables, right? So first of all, because there are two right triangles, we can use Pythagorean theorem twice. That gives us two equations. For example, in triangle XON, we have XON is this one. XN squared equals OX squared plus ON squared, right? And this gives us, what is XN? XN is 19, right? 19 squared equals OX squared. OX squared is just X squared. ON squared is Y over 2 squared, right? And this can be simplified to Y squared over 4. So we have found one equation in terms of X and Y, right? So you can use similar method to use the Pythagorean twice in another right triangle. So this is one of the right triangle. In right triangle, well, we can use this one as well. O. OYM. So in right triangle MOY, according to Pythagorean theorem, we have another equation, which is my squared equals OY squared plus OM squared, right? And my is known to us, which is 22 squared equals OY is y square. OM square is this one, right? So it's x squared over 4, right? So we have two equations. Equation number 1, equation number 2. If you have two unknown variables and two different equations, generally speaking, it's very likely we can solve x and y, right? Of course, sometimes there's no solution, and sometimes there are unlimited number of solutions. But we can try to solve this system of equations, right? So if you combine equation number 1 and number 2, this will give you okay, let's find these numbers first. 19 times 19. Okay, how do you solve an equation like this? Okay, first of all, we can times the 4 to both sides to eliminate the fractions. Okay. Let's just add them together, okay? So if you add number 3 and number 4, this will give you, the left side is 8, 4, 5, right? Equal to the right side, which is 5x squared over 4 plus 5y squared over 4, right? And then we can multiply both sides using number 4. So this gives us x squared plus y squared. Oh, multiply both sides using 5 over 4, right? To both sides. So this gives us 845 times, sorry, 4, should be 4 over 5 times 4 over 5, and this gives us 676, right? Okay, so if you know x squared plus y squared is 676, then according to Pythagorean theorem, you know xy squared, right? So this equals xy squared. Therefore, we know xy should be the positive square root of 676. And that's actually a perfect square number. And this gives us 26, right? So length of xy equals 26. Any questions? All right. If you need more time, just let me know, okay? Okay, don't worry, Leo. We'll go over these questions one by one. So next one, 16. Okay, in rectangle ABCD, AD is 1. P is on AB, and DB and DP trisects ADC, which means this angle is 30 degrees, this angle is 30 degrees, this angle is also 30 degrees. What is the parameter of triangle BDP? So if you need the parameter of BDP, you need this side, and this side, right? So let's try to calculate the length of each side. Okay, first of all, note these three angles are all equal, which are all 30 degrees. So let's say ADP equals angle PDB equals angle BDC. 90 degrees over 3, which gives us 30 degrees. And because segment AB is parallel with segment CD, this gives us angle PBD equals angle CDB, right? That angle is also 30 degrees. Therefore, triangle BDP is actually isosceles. This side equals this side. So we could conclude PB equals PD, right? And also note that triangle DBC is 30, 60, 90 triangle. And because BC equals AD equals 1, we have BD. So if this one is 30 degrees, in 30, 60, 90 triangle, we know the hypotenuse must be twice of the shorter leg, right? So this length is 2. So BD equals 2, right? And similarly, triangle DPA is also a 30, 60, 90 triangle, right? So we know this side, PD, must be twice of AP, right? So if we let DP equals X, then AP must equal half of X, right? Because we want to solve X, we want to solve the length of DP. So we just let that side be X, and therefore we have 1 plus X over 2 squared equals X squared, which gives us 1 plus X squared over 4 equals X squared. And that gives us 3 over 4x squared plus 1 is 0. Oh, sorry, equals 1. So you don't have to memorize the relationship between each side brutally. If you don't know that, you can just use Pythagoras theorem to get it by yourself. So x squared must be 4 over 3. And x must be 2 over square root 3, which can be simplified to 2 over 3 times square root 3, right? Okay, then we know the parameter of BDP, which means DP plus BP plus BD is 2 over 3 square root 3 times 2, because these two sides are equal, plus BD. BD is 2, so eventually you will have 2 plus 4 square root 3 over 3, right? Okay, have a look at the solution here. Any questions, just let me know, okay? Okay, next one. Somebody says 18. Okay, again, if you need more time, just let me know, okay? Otherwise, I'll jump to the next one. Okay, triangle ABC has 12, 16, 20. So is it a right triangle? Probably is, right? Because 12 squared plus 18 squared equals 20 squared. Or if you divide each side with a 4, you will have a 3, 2, 5, 2, 4, 2, 5, right? So triangle ABC is actually a right triangle. Okay, AB is a shorter side, which is 12. BC is 16. AC is 20. And if D is on AC, such that AD is 12, ADB. Okay, find the area of ADB. So basically we have AD is 12 and this side CD is 8, right? Okay, first of all we can say because AB squared plus BC squared equals AC squared, we know angle ABC is 90 degrees. And this actually tells us the area of ABC can be calculated by 1/2 of AB times BC, right? Which 1/2 of 12 times BC is 16. That's 96, right? Also note that this triangle ABD and the larger triangle ABC, they share the same height from this side, right? So suppose I draw a line BE perpendicular to AC. Then the red triangle and triangle ABC share the same height here. Okay, so we could say the area of ADB is given by 1/2 of AD times H, right? And it's actually 1/2 times AD. AD is 12 times H, which is 6H, right? So the problem is, do you know H? Of course, you can solve that, right? Because we know the area of triangle ABC is 96, that is 1/2 of AC times H, right? And AC is 20. Therefore, we can easily solve H. Okay, I'll just write it here. So we have 96 is 10H, which gives us H is 9.6, right? And if you know H, of course, the area of ADB is 6 times 9.6, which is 57.6, right? Of course, it's better to write your reasoning incomplete. Well, you should say draw BE perpendicular to AC at point E, and then let BE be H, right? And you should write it here before you use the letter H, right? Okay, any questions? Okay, if not, let's have a look at the next one. Question 19. Riders on a ferry wheels travel in a circle in a vertical plane. A particular wheel has a radius 20 feet and revolves at a constant rate of 1 revolution per minute. 1 revolution means 1 round, or 1 turn per minute. How many seconds does it take a rider to travel from the bottom of the wheel to a point 10 vertical feet above the bottom? Okay, first of all, it's better to draw a diagram to illustrate the situation here. So suppose we have a ferry wheel here, and this is the center. Then this is a radius, and there's another radius. Okay, so let's call this point O, A, B, and this is point C. Okay, radius 20 means OB is 20, OA is 20, and okay, a rider. How many seconds does it take a rider to travel from the bottom of the wheel to a point 10 vertical feet above the bottom? Okay, so we know AC is 10, so OC is also 10, right? So we can say let O be the center of the wheel, and then let A be the bottom of the wheel, and then let B be the point on the wheel. That is 10 feet from the bottom. Then let point C be the foot of the perpendicular from B to OA. Therefore, we know CA must equal 10. Of course, the unit is feet. And according to the setup, we know OC equals OA minus CA, which is also 10 feet. And OB is 20 feet. And angle OCB is 90 degrees. Therefore, we know this triangle here, OCB, this angle is 30 degrees, right? Because this side is 10, this hypotenuse is 20, so this is a 30, 60, 90 right triangle. So AOB is 60 degrees, and angle CBO is 30 degrees. So there are 360 degrees in a full revolution, right? And there is 1 minute or 60 seconds in a revolution. It takes 60 times 60 degrees over 360 degrees, which is 10 seconds for the rider to go from point A to B, right? because you know this angle is 60 degrees, right? So it will use 1/6 of the 1 minute, or 60 seconds. 1 minute is 60 seconds, right? So the final answer is it will cost him 10 seconds. Okay, any questions? Okay, next one, 23. Okay, in a triangle ABC, AB equals AC, so that's an isosceles triangle. And BC equals square 3 minus 1. We know the length of BC, and BAC is 30 degrees, so let's label them. This is point A, B, C. BAC is 30 degrees, and BC is, okay, find the length of AB. Okay, so does it ring any bell? If you have 30 degrees, how do you use that? Usually when you have a right triangle, you can use 30 degrees, right? So if you have no obvious tools to use to find the length, you can try introducing the 30, 60, and 90 triangle by drawing the altitude from B to AC, right? So probably you can draw a extra line here. Let's try this. So we could draw BH. Yes, it measures 75 degrees, but 75 degrees is not a special angle, right? Probably you'll figure out another way to solve this. So we could draw BH that is perpendicular to AC at point H. Then we introduced a 30, 60, and 90 degree right triangle, right? Then we could let AB equals X. Then we know AB is isosceles. AB is a hypotenuse. So BH must be half of it, right? Then we know BH must be half of X. And of course, you also know AH in terms of X, right? Therefore, AH must be square root 3 over 2X, right? What else? Okay, we know AC is AB. We haven't used this information yet. AC equals AB, so AC is also X, right? Therefore, you can express HC as AC minus AH. So put all the values in. Put both of the values in. AC is X, AH is square root 3 over 2X. So that is the length of AC. Okay, what else can we use? We can use Pythagorean theorem in this triangle here. Use this triangle. So we could say in right triangle BCH, According to the Pythagorean theorem, we have bh squared plus hc squared equals bc squared, right? Because we know the length of BC, so probably we can establish the equation in terms of x. So this gives us BH is x over 2. So BH squared is x over 2 squared. Plus HC. HC is x minus square root 3 over 2x and then squared. Equals BC. BC is given to us. Square root 3 minus 1 squared, right? So basically you need to solve an equation like this. You need to expand both sides. Okay, x squared plus 2ab, which is square root 3x squared, right? And plus 3 over 4. Sorry, this should be negative. X squared equals the right side. Right side should be 4 minus 2 square root 3, right? And this gives us 2x squared minus square root 3x squared. X squared is a common factor. Equals 4 minus 2 square root 2. And put 2 in front. So divide both sides using 2 minus square root 2. And this gives you x squared equals 2, right? And x must be positive, so x equals square root 2. Okay, that's the length of the desired AB, right? Do you get it? Okay, so that's part of the homework questions. I hope you understand better now, okay?